Understanding the risk associated with aluminum wiring involves several factors, primarily the alloy used, the application of antioxidant compounds, and proper installation techniques. The older aluminum alloy, designated -1350, was prone to creep and resulted in poor conductor-to-connector contact. This creep characteristic means that the metal would deform under pressure over time, leading to loose connections and increased resistance, thereby causing overheating and potential fire hazards. The newer aluminum alloy, the -8000 series, was developed in the 1970s specifically to address these shortcomings of the -1350 alloy. The -8000 series has improved mechanical properties that reduce creep and enhance connection stability. Larger wire sizes, generally 8 American wire gauge and above, exhibited fewer problems with the older -1350 aluminum wiring due to their increased surface area and improved heat dissipation capabilities. However, it's crucial to inspect all aluminum wiring, irrespective of size, for any signs of potential issues such as loose connections or corrosion. Antioxidant paste or gel plays a vital role in ensuring reliable aluminum connections. It should be applied to all aluminum connections regardless of the alloy or size of the wire. Aluminum oxide is a poor conductor of electricity, and its formation on the surface of aluminum wiring can significantly increase resistance at the connection points. The antioxidant compound prevents the formation of this oxide layer, thereby maintaining a good electrical contact. While the UL standard often defers to the connector manufacturer's recommendations regarding antioxidant usage, it is a general best practice to use antioxidant for all aluminum connections to mitigate the risk of oxidation and subsequent connection failures. Copper possesses superior conductivity compared to aluminum, which means that for a given current carrying capacity, a smaller copper conductor can be used than an aluminum conductor. However, aluminum is lighter and more economical than copper, making it an attractive alternative in certain applications. Aluminum oxide is indeed a poor conductor compared to copper oxide. Copper oxide does not impede the electrical current as much as aluminum oxide. But with the use of antioxidant paste, this issue with aluminum oxide is effectively addressed, allowing properly installed aluminum wiring to perform comparably to copper wiring. Copper is often considered more forgiving in terms of installation errors. Small deviations from optimal torque or slight surface imperfections may not critically compromise a copper connection. In contrast, aluminum connections demand greater precision and adherence to best practices to ensure long-term reliability. To achieve an aluminum installation that is as reliable as a typical copper installation, several key measures must be implemented. Firstly, all connections must be meticulously cleaned to remove any existing oxidation or contaminants. Secondly, a generous amount of antioxidant compound should be applied to all contact surfaces before making the connection. Thirdly, it is essential to use a calibrated torque wrench to tighten the connections to the manufacturer-specified torque value. Finally, regular inspections should be conducted to identify and rectify any loose connections or signs of corrosion. The recommended torque for aluminum connections is typically around 50 inch-pounds. However, the precise acceptable torque range can vary depending on the specific type of connector and the wire size. It is imperative to consult the manufacturer's instructions for the specific connector being used to determine the correct torque value. The accuracy of the torque wrench is paramount in ensuring reliable connections. A calibrated torque wrench should be used, and its calibration should be checked periodically to maintain accuracy. Over-tightening can damage the conductor or the connector, while under-tightening can result in a loose connection, both of which can lead to overheating and failure. When a lug specifies a torque of 50 inch-pounds, it is not simply a target value but rather a critical parameter that must be adhered to within a reasonable tolerance. The acceptable range around this value depends on the connector design and the wire material. However, deviating significantly from the specified torque can compromise the integrity of the connection. Copper connections may tolerate a wider torque range due to the greater malleability and conductivity of copper, but aluminum connections are more sensitive to torque variations due to the properties of aluminum and its oxide. Even if the Amanis 8000 series aluminum alloy effectively addresses the issues associated with the older Amanis 1350 alloy, the availability of Amanis 8000 series wire in all sizes may be limited. Some suppliers may primarily stock the Amanis 1350 alloy, particularly in certain sizes, due to cost considerations or existing inventory. The National Electrical Code does not mandate the use of the Amanis 8000 series aluminum for all wiring applications. It does stipulate that the Amanis 8000 series must be used for certain types of insulation, such as RHH, because these insulation materials can exacerbate corrosion and connection problems with aluminum wiring. The code requirements are based on extensive testing and analysis of the compatibility of different insulation materials with aluminum conductors. In summary, to mitigate the risks associated with aluminum wiring, especially in service lateral applications, consider firstly, using the Amanis 8000 series aluminum alloy whenever possible, particularly for new installations or replacements. Secondly, applying antioxidant compound to all aluminum connections, irrespective of the alloy or wire size, to prevent oxidation and ensure good electrical contact. Thirdly, using a calibrated torque wrench to tighten all connections to the manufacturer-specified torque value. Fourthly, inspecting all aluminum wiring regularly for loose connections, corrosion, or other signs of potential problems. Fifthly, adhering to the National Electrical Code requirements regarding the use of specific aluminum alloys with certain insulation types. These measures, when diligently implemented, can ensure that aluminum wiring installations are as safe and reliable as copper wiring installations. Remember that electrical work can be dangerous and should only be performed by qualified professionals. Always consult with a licensed electrician before making any changes to your electrical system.